Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and good day to all of you. So today we will discuss questions that involve in terms of limits and continuity. For the question 1, by using a numerical method, find the following limits. So you must solve these questions in terms of numerical methods. So in order to solve this question, for example, question A, we can solve by choosing at least 3 number from the left and 3 number from the right. So we can choose a 3 number from the left and 3 number from the right in order to solve these problems. So for example, x approaches to 4. So here should be 4. 3 number from the left, we can choose 3.9999, okay, and then 3.999, and then 3.99. From right, maybe we can choose 4.0001, 4.001, and then 4.01. okay, and then this value that we choose from the left and from the right, we can substitute in the equation cos theta minus 4 minus 1 divided by 2 theta minus 8. Make sure when you use your calculator must be in terms of radian, because this value in terms of radian. When we choose 3.99, we can get 0.0025. When we choose 3.999, we can get 0.00025, and then the last one we can get 0.00025. Also a same thing from the right, we can get negative 0.00025, and then if we substitute 4.001, we can get negative 0.00025, and if we substitute 4.01, we can get negative 0.0025. From this numerical value, we can see that if the value of theta approaches to 4 from the left and approaches to 4 from the right, the value is approximate to 0, both sides, from left and from right. So we can conclude that limit theta approaches to 4 for the function cos theta minus 4 minus 1 divided by 2 theta minus 8 equal to 0, since the value from the left and from the right is approaches to 0. So that one is for question A. Okay, for question B, also a same thing. From here, we want to solve limits x approaches to 0.2. So we can choose 3 value from the left and 3 value from the right. Okay, for example, this one 0.2. okay, sorry here, wait, this one is 0.2, and then from the left, maybe we can choose 0.1999, okay, and then 0.199, and the last one 0.19. You must choose at least 3 number from the left and 3 number from the right. Okay, for From the right, we can choose 0.2001, 0.201, and 0.21. This one from the right. Okay, and then after we substitute in the function a square root of 10x minus 2 square divided by 10x minus 2, we can see that after we substitute 0.19, we can get -1. This one also -1, and then this one also -1. This one no need to substitute, and then from right we can get 1, 1, 1, 1. If we can see here, from the left we can get -1, and then from the right we can get 1. So from the left is not equal to from the right. We can conclude that limit x approaches to 0.2 for the function square root of 10x minus 2 square divided by 10x minus 2 does not exist, because limit x approaches from left is not equal to limit x approaches from right. We should know that limit should be exist from left and from right. Okay. Okay, for question 2, evaluate the following limits analytically. For question A, we have limit x approaches to 0 for the function 1 minus cos 4x divided by x squared. If we substitute directly x approaches to 0 at x value, we can get 0 divided by 0. Since your answer is 0 divided by 0, it is in terms of indeterminate form. So we need to use the other methods in order to solve this problem. So we can use the identity first in order to change the cos of 4x here. This one we can use the formula of sine square a over 2 equal to 1 over 2 1 minus cos a. Okay, so from here we can see that 2 sine square a over 2 equal to 1 minus cos a. So from this equation we can see that limit x approaches to 0 equal to 2 sine square 4x over 2. This one by using this identity, and then divide by x squared. Okay, and then we can simplify these equations. We can get limit x approaches to 0 to sine square 2x divided by x squared. So both sides, denominator and numerator is the power of 2. We can simplify f. This 2 we can put outside because it is constant. So 2 limits x approaches to 0 sine 2x divided by x the power of 2. So we know that by using trigonometry identity, this one we can divide by times by 2, because we want to modify the angle should be equal to the denominator. Since the denominator is times by 2, so here also should times by 2. So we can see that this one is equal to 1. So we can get 2 times 1 the power of 2. So we can get 2 times 4 equal to 8. So that is the answer for question A. Okay, for question B, we have a limit x approaches to 5. 5 minus x divided by square root of x minus 1 minus square root of 2x minus 6. If we substitute directly the value of x approaches to 4 here, we can get 0 divided by 0. Since 0 divided by 0, we need to use the other method. Since this function involved in terms of square root, so we must times by conjugate, which is a square root of x minus 1 plus square root of 2x minus 6 divided by square root of x minus 1 plus square root of 2x minus 6. So this one we can get equal to limit x approaches to 5. 5 minus x, you must put in the bracket, times by square root of x minus 1 plus square root of 2x minus 6 divided by, when you expand on the denominator parts, since times by conjugate, you can get negative x minus 1 minus 2x minus 6. Okay, since after you simplify this one, we can get limit x approaches to 5. Okay, on the denominator part, 5 minus x times by square root of x minus 1 plus square root of 2x minus 6. So on the denominator part, after you simplify, you can get this one. You can get x minus 1 minus 2x plus 6. So you can get here negative x plus 5. So this negative x plus 5, we can simplify with this one. So here you can get limit x approaches to 5 square root of x minus 1 plus square root of 2x minus 6, and then we can substitute x equal to 5 at x value, so you can get this one equal to 4. So that is the answer for question B. Okay, now looks on question C. Also same thing, you have limit t approaches to 1, 3t square minus t minus 2 divided by t square minus 1. If you substitute directly t approaches to 1, so you can get 0 divided by 0. Okay, since your function involve polynomial function, so we can solve this equation by factorize both on the denominator and numerator. So this one we can get t minus 1 times by 3t plus 2 divided by t minus 1 times by t plus 2. So we can see here this t minus 1 we can simplify, and then we can substitute the t equal to 1 at this t value, so we can get 5 over 2. So that is the answer for question C. Okay, for question D, we have limit x approaches to negative infinity, set 4x6 minus x divided by x cubed plus 5. For this equation, if we substitute directly infinity, so you can get infinity divided by infinity. Since infinity divided by infinity, so that is not the answer. We must find the other method, since it's involved in terms of approaches to infinity, we can solve using divide by the highest power of denominator. The highest power of denominator in this case is x cubed. So all the items in this function must be divided by x cubed. So we can get 4x6 minus x divided by x cubed divided by x cubed plus 5 divided by x cubed. Okay. Since on the upper parts involve square root, so you must modify in terms of square root. So we know that x also equal to square root of x square. But here x approaches to negative infinity, so here must be negative. Okay, so we have x cubed, so it is equal to negative sec x square x cubed, also equal to negative sec x6. So on the upper parts, we must divide by negative sec x6. Okay, so it is become negative, can combine negative square root, can combine negative outside here. So 4x6 divided by x6 minus x divided by x6. Okay, so this negative, we come out with this negative. Okay, we choose because that one is negative. Okay, divide by x cubed divided by x cubed plus 5 divided by x cubed. So we can simplify this one. We can get 4. Here is 1 over x5. Here is 1. Okay, so after we simplify this one, we can get limit x approaches to negative infinity, square root of negative here, 4 minus 1 over x5 divided by 1 plus 5 over x cubed. And then we substitute infinity with x value. So then we can get negative sec 4 minus 0, because 1 divided by infinity is 0, divided by 1 plus 0. So we can get negative sec 4. Okay, also equal to negative 2. So that is the answer for question D. Okay, for question E, we have limit x approaches to 7, x squared minus 49 divided by sec x plus 2 minus 3. So this one also is same thing. If we substitute x equal to 7 at x value, we can get 0 divided by 0. Okay, and then this one involve a square root, so we can times by conjugate, which is x plus 2 plus 3 square root of x plus 2 plus 3. So when we expand this one, we can get limit x approaches to 7. Okay, so this one x squared minus 9, here it's become x minus 7 x plus 7 times by square root of x plus 2 plus 3 divide by, okay, x plus 2 minus 9. So you can see here this one become x minus 7. So this one x minus 7, we can simplify with this one. So you can get limit x approaches to 7, x plus 7, make sure puts in the bracket, square root of x plus 2 plus 3 divided by 1, no need to write. And then we can substitute x equal to 7 at x value, so you can get 84 is your final answer. That one for question 2E. Okay, so now looks on question 3. It's given to you in terms of piecewise function and a graph. So you want to find limit x approaches to negative 2 from the right. So we can see here, negative 2 from the right is this one is the line negative 2 from the right. So when from the right is approaches from the right, you must see this one and stop here. So this one is 0. So 0 is your answer. Okay, the other one, limit x approaches to 0 from left. From 0 from left. This is the line 0. And then from left is this line stop here. So that one is negative 4. Okay. And then limits x approaches to 4. Okay. Limit x approaches to 4. Here is the line limit x approaches to 4. So we need to check from left and from right. From left is stop here. From right also stop here. So that one is 12. Okay, and then function f6. 6 is this value. So we must choose the value that including 6. Okay, including 6 is this one because this one is not including, this one is not including. So the value is 8. So your answer is 8 for question D. Okay, and then for question E. Okay, for question E, this one, we want to find limit x approaches to 6. Limit x approaches to 6. So this is the line 6. Approaches to 6 from the left is stop here, which is 12. Approaches to 6 from right is stop here, which is 4. Since left and right does not equal, so the value is does not exist. Okay. Okay, and then question F. Okay, for question F, we want to find the value of A. Okay. Question F, we want to find value of A if limit x approaches to A for function fx equal to 5. Okay, since fx equal to 5 is touch the fx equal to x squared minus 4. So x squared minus 4 equal to 5. Okay. Okay, so we can choose here x squared minus 4 equal to 5. So we can solve this problem because x approaches to A. So a squared minus 4 equal to 5. So a squared equal to 9. So a equal to plus minus 3. But in this case, we must choose a equal to 3 because according to the graph. Okay, you cannot choose negative value. And then G, determine the interval that fx continuous based on the figure 3.1. So it is only continuous at all the value except at x equal to 6. Okay, at x equal to 6 is not continuous. So maybe you can write in this form. For question G, negative infinity until negative 2, not including, but union including negative 2 until 4, not including union. For okay, at value of 4 also not continuous. Okay, 4 until 6, union 6 until positive infinity. So that is the value for G. Okay. Okay. Now looks on question 4. Given that ft equal to piecewise function, so find the domain of ft. Okay. Domain of ft, we can see that it is start from greater than negative 2, and then greater than negative 2 is including, because less than negative 2 we don't have value of t. So here the domain is equal to including negative 2 until positive infinity. So that is a value of domain. Okay, and then question 2, find the value of a and b if the function is continuous every t. Okay, so this one we want to find for question A2. The value of a and b we can get by using a limit. We know that limit from left should be equal to limit from right, and then it is involved two unknowns, so you must find at least two equations. So we can choose limit t approaches to -1 from left for function ft equal to 5. Okay, from left, which is the function if 5t, so substitute, you can get 5. Okay, and then limit t approaches to -1 from right for function ft, we can get 2a, this one substitute with -1, and then -2b. Okay, so this one you can get -2a -2b. So we know that left should be equal to right, so therefore -2a this one is 2b, -2a -2b should be equal to 5. So this one is one equation. Okay, the other one we can choose limit t approaches to 1 from left for function ft. Okay, 1 from left, we can see that the this one. Okay, this one we can see that the equation is from left -1, which is 2a times by 1 -2b, so you can get 2a -2b, and then limit t approaches to 1 from right for function ft, we can get 6 -13, t equal to 1, so here you can get -7. So since this one is equal, limit from left equal to limit from right, so we can get 2a -2b equal to -7. So this is equation 2. So by solving these two equation 1 and 2, okay, so we can get a equal to -3 by using simultaneous equation, and then b equal to 1/2. So that is the answer for question A2. Okay, for question B, find a value of a such that the function gx is a continuous everywhere. So at point x equal to a, of course, when it is continuous, so limit must be defined. So we can prove that limit x approaches to a from left for function gx must be equal to limit x approaches to a from right for function gx. So this one, limit x approaches to a from left, which is x squared plus 6x, okay, equal to limit x approaches to a from right, which is 2x minus 4. So we can substitute value of a. You can get a squared plus 6a equal to 2a minus 4. So this one we can solve. We can get a squared plus 4a plus 4 equal to 0. So this one we can get after factorizations. This one a 2 plus plus. Therefore, A equal to -2. So that is the answer for question B. Okay, that's all. Thank you.